Hi everyone, so let's talk about sort integer by the power value. So you're given an integer x, so you want to keep track of the number of steps. You want to transform from x into 1. So if x is even, you are going to divide it by 2. If x is odd, you have to multiply by 3 and then plus 1. And then for example, if x is equal to 3, the number of steps is actually equal to 7. And I'm going to just briefly talk about the definition in the example, and then you'll be able to understand pretty quickly. So example 1 should be too easy to actually go through, but I'm going to talk about example 2. So you have low to high, right? So you're traversing the low to high. So low is going to be 7, 8, 9, 10, and 11, right? And you need to just keep for every each value inside this array, right? You need to keep doing the math. So if x is even, you do that. If x is odd, you do that, right? Then you will get what? You will get another array. I'm gonna say this is gonna be 16, 3, 19, 16, and 14, right? Alright, so this is actually the array that I just write down, right? So we need to sort this array. Alright, so we sort. So let me find out another color. So sort is going to be what? 3, 6, 14, 16, and 19, right? Now you have the integer k, right? Integer k represent the position after you sort, right? So let me change another color. So this is going to be 4, right? So what does 4 actually mean in position 4? Basically the k doesn't start from index 1. Doesn't start from index 0, it starts from index 1, right? So when k equal to 4, it's actually represent this one, 16. So 16 is actually right here before you sort, right? And then 16 corresponding index, I mean the traversal from low to high is 7, right? So that's why you return 7. Alright, so this is actually the problem after you sort and before you sort. And then if there's a number, which in this case, this is 12 to 15, right? But the problem is what? The power of the number is actually duplicate, right? You have 19, 19, 17, 17. And you cannot swap the order somehow. Like for example, 14 represent this one, right? 15 represent this one. You cannot swap after you sort, and then when you go for the index, then this will actually mess up. So how do you actually do this? You can actually use the HashMap and PriorityQueue. So HashMap, I'm going to say HashMap. The key is going to be integer, and the value is going to be integer, right? So key represent the value between low to high, and the value inside HashMap is going to be represent the number of steps, right? Number of steps, right? So if there's a number that they will keep doing the same number, right? And then you will just use HashMap.contains key. So the time is going to be all of 1, so it will be quicker. So if you just keep traversing again, then basically this is going to be time, and then it's going to be TLE for sure, right? And then I have another one. It's going to call PriorityQueue. PriorityQueue. This is actually really tricky. So I'm just say PQ. I'm going to sort the PQ from largest to smallest, right? So I will actually just get rid of the smallest one, right? And then pick the largest one first, and then basically when I put into my PQ, right, I just have to keep track of the k. So if the PQ.size is actually greater than k, I'm going to pop. So if that is greater than k, right, I'm going to pop the largest one because I don't need it. So after the folder between the low to high, I just have to pick the first one in the PQ. So here it is. So how do I say this? So when I add, right, I need to go through the power function. So I have a power function before I add, and then when I poll, I need to making sure the PQ.size is actually greater than k, and then that will be what that will actually sort this value in general. Like this will be what 19, 16, and then 14, 16, 3, right? But k is 4, right? So I will pop this one, and it's definitely going to be 16, right? And 16, the index for 16 is 7. So for every single time I add into PQ, I need to go through the power function, right? So this is basically the solution. So I'm not going to talk too much. So let me do this. So I need a global variable HashMap. And then I'm going to initialize my map, the new HashMap. Alright, and then I'm going to put the default value, which is 1 and 0. This is because when I traverse from what? Traverse from I equal to low to I less than equal to high, right? You have to include the high, right? Then you need to find out the value inside the map, right? And then this is going to be a last value, which is going to be a 1. So there's no 0 step for integer 1, right? So I have a power function. I'm going to say public in power function. I'm going to call the num, right? So if the map that contains key is actually find out the map num, I will just have to return map.get num, right? Now, what happens if you cannot find it, which is a new value, right? So I'm going to say step is actually equal to 1 plus. So if I just have to keep recursively call the function until the num is actually equal to 1, right? So if the num is actually equal to num mod 2, sorry, num mod 2 is actually equal to 0, right? Then I will just have to I'll have to divide it by 2, right? So I will call the function power num divided by 2. And then if not, then I will just call the function, say 3 times num plus 1, right? Then, and don't forget, you need to store this step for the current num, right? So you don't have to traverse again. Then we have to return the steps, right? Now I need to have a priority queue. So priority queue, I'm going to store the integer, right? And basically store the index. I mean, this is the tricky part. So priority queue. Alright, now I need to use the lambda expression. So it's gonna be a comma b, and then to the array. So I'm going to sort the index based on the power function. So it's going to be power a. If power a is not equal to power b, right? Then I will do question mark, right? If this is not equal, then I will have to say power b minus power a. Okay, why is power b minus power a? We need to sort from largest to small as well, right? So the largest one will just pop out, right? So which one? Hold on. For this one, this is gonna be 19, and 19 is going to pop, right? We don't need 19. But what happens if they are equal? What happens if they are equal? I need to still making sure this is going to be from largest to smallest, right? So it's going to be what? B minus a. And a and b are all index. The value between low and high. So here's it. So pq.add, I need to add I only. Because when I put I in there, I will definitely call the power function. And then power function will just keep comparing, right? And then this is basically the solution. So if pq.size is actually greater than k, right? Just poke. Or poke, because it's all bound, right? And I don't need it for sure. And then the return value is going to be pq.p. And this is pretty much the solution. Let me try to learn. Okay, yes. And submit. Alright, here we go. So let's talk about time and space. Be honest, this is going to be hard for the time, but at least it's the unlock n for sure. But you have to multiply by something, and which is the time for the power function. And I'm not guaranteed this one, because you can actually get a number if you did traverse once already. But the problem is if you get a new number, this is not countable for sure. And this is, I mean, priority queue, is sorting, so it's definitely unlock n. So n represents the length between high minus low, right? And then the space is going to be all of n, and this is pretty much a solution. So just making sure you know what is list doing, pq.add, pq.pull, and then pq.pick, and how you sort this value inside the pq. And this is the solution, and I will see you next time. Bye.